So welcome back to one more video on design of reinforced concrete structures using working stress method and limit state method. In this video you will learn how to calculate the load on beam when the beam supports one-way slab. We will understand this with the help of numerical example. The slabs are classified as one-way slab and two-way slab on the basis of Ly by Lx ratio. The load on the beam depends on type of slab. When Ly by Lx ratio is greater than 2, then such slab is called as one-way slab. If the beam supports one-way slab, in that case 50% load of the slab from each side is transferred to that beam in the form of uniformly distributed load. But if the same beam supports two-way slab, in that case, you know that two-way slab means when Ly by Lx ratio is less than or equal to 2. In such case, we call this slab as two-way slab. So in this case, the load from the slab is transferred to the beam in the form of triangular and trapezoidal fashion. The triangular load on the shorter beam and trapezoidal load on the longer beam. Only Ly by Lx is not the sufficient condition to decide whether it is a two-way slab. In case of two-way slab, we must have the beams all over the slab. For example, here, in case of one-way slab, we can have beams only on two sides of the slab. Whereas, if we want two-way action in the slab, then we must have the beams on all the four sides of the slab. Then only it can act as two-way slab. So if it is a one-way slab, it will transfer the uniformly distributed load to the beam, whereas if it is two-way slab, then it will transfer the load in the form of triangular and trapezoidal fashion. So now we will actually calculate the load with the help of numerical example. Let us consider a slab having dimension 6 meter by 8 meter. Since it is a very large span, one more beam is there as shown in the figure. The beam divides the slab into two slabs. So this is nothing but a one-way continuous slab, and the dimension of each panel is 3 meter by 8 meter. The other data considered for calculation of the load on the beam is depth of the slab as 200 mm, live load 4 kN per meter square, floor finish 1 kN per meter square. Now this size of panel is 3 meter by 8 meter. So Ly by Lx is greater than 2. Therefore it is one-way slab. So now let us see how to calculate the load on beam when the beam supports one-way slab. Because of central beam, the slab will act as one-way continuous slab. Now let us consider there are two panels of this one-way continuous slab, that is S1 and S2. And let us see how to calculate the load transferred from this slab S1 and S2 on central beam. So load on beam is equal to half of the load from slab S1 plus half of the load from slab S2. So 50% of S1 load and 50% of S2 load will be transferred to this beam in the form of uniformly distributed load. Now let us calculate this load from slab S1 to beam. So you know that the thickness of slab is 200 mm. So dead load of slab is 25 into 0.2. 25 is density of RCC. So 25D is the dead load of slab. So it is 5 kN per meter square. Floor finish is given in the problem, that is 1 kN per meter square, and live load is 4 kN per meter square. So let us add this load. If you add this, you will get 10 kN per meter square. What does it mean? It means that on 1 meter by 1 meter area of slab, total load is 10 kilonewton. So 1 meter square area, the load is 10 kilonewton. So what is the total area which is transferring load to the beam? It is 1.5 meter by 8 meter. So if you multiply this 10 by 1.5 by 10, 1.5 by 8, you will get total load which is transferred from slab S1 to that beam. So 10 is the load which is kilonewton per meter square, and total the shaded area is 1.5 by 8. So we get 120 kilonewton. So 120 kilonewton from slab S1. Similarly, 120 kilonewton will be from slab S2. So total load which is transferred to this beam from the slab is 240 kilonewton. But this is the total load. For bending moment calculation, etc., we need uniformly distributed load. So to get the uniformly distributed load on this beam, uniformly distributed load on the beam will be 240 divided by 8, which is 30 kilonewton per meter. So once you calculate the uniformly distributed load on beam, so here we got 30 kilonewton per meter. You can show it on the beam. Uniformly distributed load 30 kilonewton per meter and span is 8 meter. Now you can calculate the design bending moment and shear force for further calculation. But this is the load which is transferred from slab to beam. If you want to design the beam, you have to add the self-weight of the beam also. So initially we do not know the size of the beam, so we have to assume the self-weight of the beam. Normally 3 kilonewton per meter self-weight is added to this load to get the design load on the beam. 3 kilonewton per meter load means it is approximately the size of the beam is 300 millimeter by 400 millimeter, or 230 millimeter by 500 millimeter size. So this self-weight is added to the load which we have calculated from the slab which is transferred to the beam. So total load will be approximately 33 kilonewton per meter, for which you need to design this beam. This is all for today. Let us meet in next video. Thank you.